On the windswept Texas coast, a gleaming stainless steel rocket stands ready, Ship 38, SpaceX's latest Starship prototype. Its polished surface reflects the early morning sun, a testament to years of relentless engineering and ambition. This is not just another test article, it's a symbol of SpaceX's drive to push the boundaries of what's possible in spaceflight. Ship 38 isn't here to launch just yet. Instead, it faces a gauntlet of critical ground tests. Trials designed to push its systems to the limit and prove its readiness for the challenges ahead. These tests are the gateway to orbit, and NASA is watching every moment with intense interest. Their eyes are fixed on the data, knowing that each result could bring them closer to their lunar ambitions, or set them back. NASA has staked its Artemis lunar program on Starship's success, awarding SpaceX a multi-billion-dollar contract for a lunar lander. This partnership is historic, blending government vision with private innovation. Without Starship, there's no Artemis lunar landing. The dream of returning humans to the moon, and eventually reaching Mars, depends on this vehicle's success. Every test at Starbase is a data point for NASA, showing how close or far SpaceX is from delivering. Each sensor reading, each pressure test, and every engine firing is scrutinized for clues about the rocket's readiness. A successful campaign builds confidence, a failure raises tough questions about timelines and budgets. The stakes are high, and every outcome ripples through both organizations. The pressure is immense. Ship 38 isn't just another prototype, it's a crucial step for both SpaceX and NASA. The hopes of two organizations and the future of lunar exploration rest on its performance. SpaceX's philosophy is rapid iteration: build, test, sometimes fail, and improve. This relentless pace is what sets them apart, allowing lessons to be learned and applied faster than ever before in aerospace history. Ship 38 embodies lessons from dozens of previous vehicles. Each weld, each modification, and every patch of scorched steel tells a story of progress and adaptation. It carries the hopes of SpaceX engineers and NASA officials alike. For many, it's the culmination of years of work, late nights, and bold dreams. The stakes couldn't be higher. Every test is a step toward history, or a reminder of how difficult this journey truly is. For the public, Ship 38 is a symbol of a future that once seemed like science fiction. It inspires a new generation to look up and imagine their own place among the stars. But before Mars or the Moon, it must pass its most basic exams. The road to space is paved with rigorous checks and unforgiving milestones. It needs to prove it can handle the power of its Raptor engines. These engines are among the most advanced ever built, and their performance is critical to every future mission. The journey to Mars starts not with a launch but with careful, controlled ground tests. Each one is a rehearsal for the real thing, a chance to catch problems before they become disasters. Every hiss and rumble at Starbase is part of a larger story. It's the sound of progress, of humanity inching closer to a new era in space. It's a story about whether humanity is ready for its next step into the cosmos. The outcome will echo for generations, shaping our destiny beyond Earth. The world is watching, and the outcome will shape the future of space exploration. From classrooms to boardrooms, all eyes are on Starbase. Ship 38 stands as a bridge between dreams and reality. It's the vessel that could turn science fiction into fact. Its success or failure will echo far beyond the Texas coast. The ripples will be felt across the world, inspiring hope or caution in equal measure. The countdown to history begins here, with Ship 38 standing tall, ready to prove itself, and perhaps to change the course of human spaceflight forever. What is a static fire test? It's one of the most crucial steps before a rocket ever leaves the ground, and it's a moment that can make or break a mission. Think of it as a rocket's dress rehearsal, a full-scale practice run, but with real engines, real fuel, and real stakes. Ship 38 is fully loaded with super-chilled propellants, clamped tightly to the launch mount as if it's ready to leap skyward at any moment. The goal isn't flight, it's to ignite the engines and gather as much data as possible, simulating the conditions of an actual launch. For a few seconds, the Raptor engines roar to life, pushing against the clamps with immense force, but the rocket stays firmly on the ground. Thousands of sensors track temperatures, pressures, and vibrations, capturing every detail of the rocket's performance. Engineers watch every data point, searching for any sign of trouble. No anomaly is too small to investigate. This is the first time the entire system, tanks, engines, software, and ground support, works together as a single unit. Problems found now can be fixed on the ground, not in flight, where solutions are impossible and mistakes can be catastrophic. A successful static fire is a major milestone, required before the FAA will grant a launch license, and it's a moment of relief for the entire team. For Starship, with its 6 Raptor engines, this test is even more critical, as all engines must work in perfect harmony. It verifies that all engines ignite and run smoothly together, ensuring the rocket can handle the stresses of launch. The static fire also tests ground systems, like propellant loading, sound suppression, and the intricate choreography of launch operations. Each successful test proves Starship is more than a shiny shell. It's a high-performance machine, ready for space, built on data and determination. Without this crucial step, the rocket goes nowhere. The static fire is the gateway to the stars. Ship 38's path has been rocky. Its static fire campaign has faced repeated holds and aborts. Countdowns stopped by the computer at the last second. Aborts happen when sensors detect something off. A pressure too high, a valve out of place, a temperature too low. Normally SpaceX quickly fixes these issues, but Ship 38's problems have been stubborn and persistent. The recurring aborts suggest a deeper issue, possibly with the complex propellant loading or engine ignition sequence. Even a tiny leak or faulty sensor can halt the test. Each abort means detanking, inspection, and another long day for engineers. While aborts are safer than catastrophic failures, the string of them has raised concerns. It's a reminder that even for SpaceX, rocket science is never easy. Every setback is a lesson, but also a costly delay. Ship 38 features a major upgrade you can't see: SpaceX's innovative Crunch Wrap heat shield system. This new technology is designed to protect Starship during the most dangerous part of its journey: re-entry into Earth's atmosphere, where temperatures soar and forces threaten to tear the vehicle apart. Previous Starships lost tiles during re-entry, risking vehicle destruction and jeopardizing the mission. Even a single missing tile could spell disaster for the spacecraft and its crew. The problem wasn't the tiles themselves, but how they were attached, directly to the steel hull, which flexes and shifts under extreme conditions, causing tiles to pop off. Enter the Crunch Wrap, an intermediate layer of metal and fire-retardant felt, sandwiched between the hull and the tiles. This new buffer is engineered to handle the intense movement and heat. This buffer absorbs movement and flexing, keeping the fragile tiles secure and in place, even as the hull expands and contracts during flight. The name Crunch Wrap comes from its layered, almost crunchy appearance, reminiscent of a protective shell with multiple textures and materials. Ships 36 and 37 tested this system on the ground, but Ship 38 is the first to fly with it, putting the new design to the ultimate test in space. The Crunch Wrap is a product of SpaceX's rapid, iterative design process, where improvements are made quickly and tested relentlessly. Its success could finally solve one of Starship's most dangerous and persistent problems, paving the way for safer, more reliable missions. If it works, it's a leap forward for reusability, making Starship more robust and cost-effective for future flights. If not, the search for a better solution continues, as engineers analyze every detail and push the boundaries of what's possible. The world will be watching this crucial test, eager to see if Starship's new skin can withstand the ultimate trial and usher in a new era of spaceflight. The Crunch Wrap heat shield tackles the challenge of different materials expanding at different rates during re-entry. Starship's steel hull flexes under heat, while the ceramic tiles are brittle. The old system glued tiles directly to the hull, like sticking a teacup to bending metal. The Crunch Wrap adds a slip layer, letting the hull move without stressing the tiles. This clever engineering works with physics, not against it. For a reusable rocket, the heat shield must survive hundreds of flights. Constant tile loss isn't an option. The Crunch Wrap aims for robust, reliable protection, flight after flight. If Ship 38's tiles stay on, it's a huge win for Starship's future. Without it, reusability and affordable space travel remains out of reach. The stakes are high. A major failure, like an explosion, would halt testing for months. It would force SpaceX to investigate, repair, and possibly redesign, delaying the entire program. NASA's Artemis timeline would slip, jeopardizing the moon landing. Confidence in SpaceX would take a hit, inviting more scrutiny from regulators. The dream of Mars would seem even further away. Every setback is a reminder: building a new path to space is never easy. Ship 38's outcome will ripple across the industry. Ship 38 is the last of the Block 2 Starship prototypes. Block 3 is already in the works, but this test is the final exam for the current design. If Ship 38 fails, SpaceX must decide: build another Block 2, or risk moving ahead with Block 3 untested. A successful flight validates the Block 2 architecture and keeps the production line moving. A failure disrupts everything, forcing fixes across the fleet and pausing progress. This test marks a transition, the end of one chapter, the start of another. The data from Ship 38 will shape the rockets that take humans to the Moon and Mars. That's why the world is watching. This isn't just another test, it's a pivotal moment in the modern space race. The outcome will help decide how soon humanity reaches for other worlds. Ship 38's legacy will be written in the results.